and welcome back to Scale Me Down. In this episode we're going to build and modify this Hangar 9 Piper Pawnee Brave for towing radio controlled gliders. Remember to like and subscribe to support the channel. This is not meant to be a blow-by-blow account of the build, just my observations of the kit and the modifications required to make it into a tow plane. Let's start by having a look at the contents of this enormous box. The box is well packed, with all the high quality parts emerging damage free. The parts are all well made and covered and ooze quality. This big hatch should make installation easy. Welcome back to the workshop, and we're going to start, as the thorough instructions suggest, with the wings. I've placed an old towel down on the bench so we don't puncture any holes in the covering or mark the finish. And the process starts by epoxying in these fiberglass flap and aileron horns. The instructions get you to protect the finish on the horns with some masking tape before roughening the mating surfaces and fitting them with 30-minute epoxy. The supplied hinges are the furry Mylar types, and I prefer to fit them to one side with medium CA. Then I can fiddle the surface together and wick in thin CA. I absolutely hate this stuff though, and I always have a bottle of debonder to hand while doing it. The instructions don't mention it, but I always pin my hinges, and here I'm drilling 2mm holes to secure with cocktail sticks. We then turn our attention to fitting the servos, and this is the flap servo door. You can see that it's well made and the manufacturers have used plenty of epoxy. However, the kit uses push rods with Z-bends at one end, and at this price point they should really be ball linkages. So I'm going to make my own wing linkages. We just need to move the servo over a little to make space for the ball linkage to move. And to make that happen, I've made some little shims from plywood. There we are, much better and a bit beefier too. The instructions usefully give the length of all the servo horns, but for best performance they shouldn't really be fitted at 90 degrees. So here you can see I've mounted the aileron horns with some forward bias to provide some differential movement, and the flap horns are biased rearwards with the flaps retracted. Hangar 9 have thoughtfully pre-fitted some string to pull through all the wiring. These LED lights are included in the kit, and whilst feeding all the wiring through, I noticed that the spars were carbon fibre. We're going to have to do something with all this wiring, or this plane will be a right faff at the field. And so to tidy this lot up, I'm using multiplex 8-way connectors. Let's use the laser to make some mounts for them. While I'm carefully soldering it all up, I push the male and female components together so that the pins don't move in the plastic housings when they get warm. As well as heat shrinking the joints, I use hot melt glue for a bit of strain relief. And then we can glue them in. Much neater. Moving on to the fuselage, I like to start by fitting the landing gear so we can avoid punching holes through the covering. And on this model this is quite a substantial piece of hardware. I fit these bolts using blue thread lock. Now I can turn it over and fit the wings, sliding them onto these two sturdy carbon tubes. For my next mod, I'm cutting down the securing bolts as they're crazy long. Much better. And now we can fit the mating part of the wiring harness using epoxy. And now, when we slide the wings on, the wiring auto-connects. Moving on to the tailplane, and it's nice to see this is airfoil section. The job starts once again by fitting the horns and hinges. These go together in the same manner as the wing surfaces. You can see here that I've removed the covering ready for fitting the tailplane to the fuselage. And once again, I'm pinning all the hinges with cocktail sticks. All done nice and neat. When it came to fitting the tailplane with epoxy, I took some time here to check that it was perfectly straight. Disappointingly, I had to adjust the tailplane seat a bit to get it parallel with the wings. And sadly, the same was true of the vertical stabilizer, with a bit of adjustment required before it would sit perfectly vertical. And even then, there's this big gap between the fin strake and turtle deck. Now to the powertrain. I think this aircraft is a bit big for the 6-cell suggested setup, so I've chosen this lower KV motor from Overlander running on 10 cells at higher voltage but lower current through a HV 90 amp speed controller. On HV setups, I include this MKTEC safety switch so that I can isolate the motor during connection and disconnection with this magnet plunger. Hangar 9 have made the installation easy by including this adjustable motor box. You simply mark the motor mount using these etched guides before drilling the holes. The instructions then give a precise measurement, so by test fitting the motor we know where to fix it with epoxy. The assembly is then completed with the included triangle stock and in our case a 6mm spacer, along with some claw nuts. I was nicely surprised to find that the firewall was already fuel-proofed, and with this system it will be easy to change the power plant at a later date. The instructions walk you through fitting the cowl. You tape card markers to locate where the holes should be drilled before mounting with machine screws into pre-fitted captive nuts. Now to the elevator and rudder servos. Once again, standard servo horns are too small and XL arms are required. Just look how I had to modify the rudder linkage to get it to move without binding. Meanwhile, the elevator pushrods are joined together with this metal block after first filing flats onto the wire. This is the general layout of the tail group. You can see I don't have an issue with the supplied clevises, just the Z-bends. Notice how there's no clearance on the elevators to accommodate the rudder travel. Next, we're going to fit this multiplex tow release. I said earlier that this large hatch would make installation easy, and it has. However, now it's a problem, as the release needs to fit right here, and here's why. With a glider on tow, the extended tow line intersects the centre of gravity of both aircraft. And that means I'll have to cut away this section of the hatch and fit it permanently to the fuselage in order to fit this in there. I made these cuts on the bandsaw, and sorry the camera didn't work so I've no film. But I glued the section of hatch back, bonding it in turn to a spruce stringer that I epoxied to each fuselage frame to tie it all together. I then made these sides from birch plywood to reinforce the area. These are again tied with 30-minute epoxy to the stringer I added. I added a mount for the servo that pulls the pin on the tow release, and also these two light ply walls to tidy up and add some strength back to the hatch. Finally, I cut a notch in the canopy to clear the release and added 2 new spring latches. And just before I glue the canopy down, Hangar 9 do supply a pilot, but I think we can do a bit better. And this is a good road test for our new Creality K1 Max printer. As the landing gear is very stiff, for my final modification I've got these wheels from Cavan with a bit more give, and they're 35% lighter. And that's all we have time for in this episode. Stay tuned for part 2, where we'll fit the flight battery set in the centre of gravity and also some final scale details. We'll also carry out the maiden flight, so remember to like and subscribe, and if you press the bell icon you'll receive notifications of when we post our next video. Thanks for watching.